All right. But what if they weren't at right angles? It would be would be difficult, right? We would have to use law of cosines or sines, but it turns out that we can use something else. So let's say we wanted to add vector A to vector B. And I'm going to draw in vector A is being drawn, and then vector B is drawn tip to tail to it, and so the resultant is the black line R. So just think about it. A is pulling to the east 1, 2, 3, 4, 5, 6 units, and B, it has an eastward component of 1, 2, 3, 4, 5, 6, 7 units. So together, if I were to add up all of the, and draw in the x component of R now, okay, this is the x component of the black vector, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 units long. Well, my 6 plus 7 is 13. Let's see if it works for the y component. So the y component for A is 2. And the y component for B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. Let's draw in the y component for R. We'll start there and go all the way up to where it ends. If I count those, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's 15. Sorry. So you see that the resultant of these two vectors, of any two vectors, is really is going to have the x component that is the sum of each of the vectors x's, and a y component that is the sum of each of the vectors y's. So when I add vectors with components, what I'm going to do is I'm going to take those vectors and I'm going to resolve them into x's and y's, find their x and y's. I'm going to add up the x's to get the resultant x. I'm going to add up the resultant to get the resultant y. Then I'm going to use square root and tan theta to find the magnitude and direction. So let's do an example. So I'm going to draw a vector diagram for you of this. Okay, we've got vector A, vector B, and vector C. So vector A is 200 at 0 degrees, so it looks like this. 200 at 0 degrees, okay? Vector B is 125 at 120. So 90 degrees is here, so it's like 30 degrees off of 90, and it's not as long. It's like 125. So that's it. And then vector C is 500 at 300 degrees. So 300 degrees would be 60 degrees below the x-axis. So let's do a different color for it. Green. So if I do that, 60 degrees below would be something like this. And it's pretty long. So I could add all these tip to tail successively, but it's kind of hard to visualize the net force, isn't it? I mean, this one's pulling to the east, and this one's pulling to the west, and this one's pulling way to the east, so it may be somewhere over here. It's going to be somewhere on the left-hand side of the axis, and probably more in the downward, in the southern, so probably somewhere in the third quadrant, but I'm not really sure. So this is not one that I can use Pythagorean theorem and tan theta very easily. But what I can do is I can resolve each one of these into their x's and y's. So that's what I did. And the best way to do this is to create a chart. So 200 times the cosine of 200 is 200. 200 times the sine of 0 is 0. So the first vector, which we knew was laying on the x-axis, has a magnitude of 200 on the x-axis and a magnitude of 0 on the y-axis. 30 newtons at, actually, I think I wrote that down, but let's say it's 30 newtons at 110. It would be 30 times the cosine of 110, which is negative 10.3, and 30 times the sine of 110, which is 28.2. And then we've got 300 at 230 degrees and 300. So I found its x to be negative 193 and its y to be negative 230. If I add up all the x's, then I get an x of negative 3.30 newtons. And if I add up all the y's, I get a y of 202 newtons. So let's just kind of sketch that out. A little x, right? And a really big positive y. So this was not the same problem as the one on the other page, and I apologize. But it would be this guy right here. It would be somewhere in here like that. That would be it. I've got an x and a y, and so I can use my Pythagorean theorem, and this is in the second quadrant. So I'm going to, when I find my angle, I'm going to subtract it off of 180. Now, when you plug in tan negative 1 of 202 over negative 3.30, you get a negative 61.2 degrees. And that just simply means that it's below an axis, or it needs to be taken off of something. So you can drop that negative and then just subtract it off of